Previously, I told you about primary tables and secondary tables. And in the rules of one, I spoke about how each attribute needed to be an attribute that describes that particular item. More specifically, that attribute has to describe that particular primary key. So let's camp here for a second and talk about primary keys. The primary key is going to be the unique way that you know you can identify a specific row. And in the database community, how you actually physically build that primary key is a huge debate, even bigger than null versus not null. One side of the debate believes that it's best to have a natural primary key. A natural primary key is one that would be used in the real world. For example, a vehicle VIN number, a social security number, a name, a department name, something like that would be a good natural primary key. The other side of the debate prefers surrogate primary keys. Surrogate meaning artificial, created by the computer. A GUID, or Global Unique Identifier, or Identity Column are both good surrogate primary keys. And of course there's pros and cons on both sides of this. So on the natural primary key side, a pro is that the actual data itself is copied down into the foreign key. For example, if you have a VIN number as your primary key, then you have that same VIN number in a foreign key. So you don't have to join to go find out more about the car. A human can look at that foreign key and it makes sense. But at the same time, that can be a con as well, because if a human can see and understand the data, sooner or later, the human is going to want to change that data or add more meaning to it. So on the side of the surrogate primary keys, they would actually identify that it's best to have a primary key which is human meaningless. They would feel that it's best to have a primary key that has no meaning to humans, so humans have no reason to want to alter that primary key or add meaning to it in the future. Simply for performance, surrogate primary keys tend to be shorter, so you can place more data on a data page, which gives you better performance. Another performance aspect is that if you're using GUIDs, or Global Unique Identifiers, depending upon how they're implemented, they may cause page splits. A page split is when data is inserted in the middle of the page, and SQL Server, once that page is full, the data page has to be written to two other pages. This hurts performance in several ways. The page split itself is expensive. Pages are then only populated about 50% full afterwards, and it causes fragmentation in the database. And natural primary keys will also tend to have page splits, because most natural primary keys don't always add a new value at the end of the list. For example, if someone new comes and joins your organization and their name is Jones and you're doing a natural primary key based upon first name, last name, and say date of birth to make it unique, you will tend to have page splits in that situation as well. And the last con for natural primary keys is that they tend to be very wide and they tend to be composite, meaning multiple columns to make it unique. And these make for very clumsy joins and very complex foreign keys. When I'm working with primary keys, I actually use a system called situational modeling. And in situational modeling, what I do is I divide up the schema into 3 different areas. In the center are business entities, also called visible entities. When you sit down with the user and they describe what they want the database to contain, these will be the entities that they understand: orders, customers, products, shipping information. These are the documents they work with on a day-to-day basis. The top layer I call domain integrity. These are tables in the database just for looking up values and making sure that the domain, or what's legal for a foreign key, is correct. Examples of domain integrity tables might be a state table, maybe zip code table, color, the typical lookup tables in a database. The business users might understand what these are for, but they wouldn't describe them as primary documents. Domain integrity tables also tend to be rather static. Typically there will be some type of admin screen just to modify and maintain that information, but they don't see daily transactions the same way the business entity tables will. Then the third area would be the supporting entities. The supporting tables create the physical associative table that helps materialize or actually physically create the logical many-to-many relationship between two business entities. Earlier we saw an associative table add members to groups so that many members could be in many groups and each group could have many members. The advantage of situational modeling is that you can look at each one of these 3 different areas and decide how you want to create the physical keys based upon which area. For example, for the domain integrity tables, I prefer to use natural primary keys. This saves a join when trying to find out more about one of the business entities. For the business entity layer, I prefer using surrogate primary keys. If there's going to be no replication, which really needs to have GUIDs, I would use an identity column, but I would use a GUID column there depending upon other needs as far as replication. Where it gets tricky is the supporting entities. A supporting entity typically will have 2 foreign keys, one to each one of the different business entities. And the question then is, do we create a primary key out of a combination of those 2 foreign keys, or create a new surrogate primary key? And I've gone both ways on this, depending upon whether or not that supporting entity will also be a primary key to another secondary table. I don't like composite primary keys. So if there's going to be a secondary table that references this supporting entity, I tend to add a surrogate primary key. So primary keys, foreign keys, the way that you create them physically is key to the performance of the system.